Hello everyone, I am Vidya Patil, Assistant Professor in Department of Mechanical Engineering in Sharad Institute of Technology, College of Engineering, Yetrao. Today in lecture 3, we are going to learn the different types of gears under the subject of Fundamentals of Mechanical Engineering. In this session, we are going to cover the introduction of gears and different types of gears with applications. First, we understand what is gear. So, gear is a toothed wheel that engages another toothed mechanism in order to change the speed or direction of transmitted motion. A gear is a component within a transmission device that transmits rotational force to another gear or device. A gear is different from a pulley. In that gear, a round wheel which has linkages that mesh with each other, gear teeth, allowing force to be fully transferred without slippages. Depending on their construction and arrangement, gear devices can transmit forces at different speeds, torques, or in different direction from the power source. Gears are used to transmit motion from one shaft to another shaft or between the shafts. This is accomplished by successively engaging the teeth. So, toothed wheel that engages another tooth mechanism in order to change the speed or direction of the transmission motion. So, these gears are classified according to the relative position of their shaft axis, that is as follows. That is parallel shafts, intersecting shafts, and skew shafts. In parallel shaft, the gears are classified the spur gear, spur rack and pinion, helical gears or helical spur gear, double helical gear, and herringbone gear. And in intersecting shafts, straight bevel gears, spiral bevel gears, zero bevel gears. And in skew shaft, crossed helical gears, worm gears, that is single throated, double throated, or non throated. So, the gears according to the position of the axis of the shaft, that means the axis of the two shafts between which the motion is to be transmitted, may be parallel or may be intersecting or may be non-intersecting and non-parallel. So, gears for connecting parallel shafts, that is spur gears, helical gears or helical gears. Okay. So, first we see one by one. First we start from the spur gears. Spur gear having the straight teeth parallel to the axis and thus are not subjected to axial thrust due to the teeth load. The spur gears are the most common type of gears. So, teeth is parallel to the axis of rotation, can transmit power from one shaft to another parallel shaft. So, you can see here, this is the diagram of spur gear. So, spur gears are the simplest and most common type of gears. Their general form is a cylinder or disc. The teeth project radially and with these straight cut gears. So, spur gears are gears in the same plane that move opposite or each other because they are meshed together. If we consider the gear A and gear B, that time gear A is called and gear A rotated to gear B, that time gear A is called as a driver gear because this is turned by the motor, and gear A turn its meshes with the gear B, so it begins to turn as well. So gear B is called the driven gear. So they are in spur gears, they having the straight teeth parallel to the axis and thus are not subjected to axial thrust due to teeth load. So, spur gears are the most common type of gears. They are used to transmit rotary motion between parallel shafts, that is, they are usually cylindrical in shape, and the teeth are straight and parallel to the axis of the rotation. Sometimes many spur gears are used at once to create very large gear reductions. So, spur gears are used in many devices but not in cars as they produces large noise. So, next gear is helical gear. In helical gear, you can see the diagram of helical gear is this. In helical gears, the teeth are curved and each being helical in shape. Two meshing gears have the same helix angle but have teeth of opposite hands. At the beginning of engagement, contact occurs only at a point of leading edge of the curved teeth. So, as the gears rotate, the contact extends along the diagonal line across the teeth. So, thus the load application is gradual, which results in low impact stresses and reduction in noise. Therefore, the helical gears can be used at higher velocities than the spur gears and have greater load carrying capacity than the spur gear. So, helical gears having these spur gears are used in electric screwdriver, dancing monster, then a sprinkler, wind up alarm clock, washing machine, and clothes dryer, etc. Okay, so in helical gears having helical teeth, you can see here crossed helical gear also. This is parallel helical, crossed helical, and double helical. These are the different types of helical gears. So the teeth on helical gears are cut at an angle to the face of the gear. When the two teeth on helical gear system engages, the contact starts at one end of the tooth and gradually speeds as the gears rotates until the two teeth are in full engagement. So this gradual engagement makes helical gears operates much more smoothly and quickly than the spur gears. So for this reason, helical gears are used in almost all car transmissions, which spur gears are not used in car transmission because of the noisiness of the spur gears. So because of the angle of the teeth on helical gears, they create thrust load on gears when they mesh with each other. So devices that use helical gears have bearings that can support this thrust load. So one intersecting thing about helical gear is that if the angles of the gear teeth are correct, they can be mounted on perpendicular shaft and adjusting the rotational angle by 90 degrees. So you can see here the diagram of crossed helical gears. Again the next diagram of there, that is double helical gear, that is also called as a herringbone gear. So to avoid the axial thrust, two helical gears of opposite hand can be mounted side by side to cancel resulting the thrust forces. These are called as a double helical or herringbone gears. You can see in this figure there are the two gears are opposite hands, one having the left hand and second gear having the right hand helix. So these herringbone gears are most of times used in common applications in power transmission. They utilize curved teeth for efficient high capacity power transmission. This offers reduced pulsation due to which are highly used for extrusion and polymerization. So herringbone gears are mostly used on heavy machineries. So these are the different types of gears. Also these double helical and herringbone gears, their tooth of two row is separated by groove used for tool runout. If the left and the right inclinations of the double helical gear meet at common apex and there is no groove in between, that time that gear is known as herringbone gear. Okay. So in crossed helical gears also, the use of crossed helical gear or spiral gears is limited to light loads. By a suitable choice of helix angle for the mating gears, the two shafts can be set at any angle. So next gear is worm gear. So worm gear is a special case of spiral gear in which the larger wheel usually has a hollow or concave shape such that a portion of the pitch diameter is the other gear is enveloped on it. The smaller of the two wheels is called the worm, which also has larger spiral angles. So the figure in this figure you can see there is a worm and worm wheel. The worm gears are used when large gear reduction are needed. It is common for worm gears to have reduction of 20:1 and even up 300:1 or greater. So many worm gears have an intersecting property that no other gear set has. The worm can easily turn the gear, but the gear cannot turn the worm. This is because the angle on the worm is so shallow that when the gear tries to spin it, the friction between the gear and the worm holds the worm in place. So next here there is a non-intersecting and non-parallel. That time there is a rack and pinion. You can see rack and pinion gears are used to convert rotational motion into linear motion. The rotational motion from the pinion and the linear motion of the rack. The perfect example of this is the steering system on many cars. In steering gear mechanism, we use this rack and pinion. The steering wheel rotates the gear which engages the rack. As the gear turns, it slides the rack either to the right or left, depending on which way you turn the wheel. That means if you want to take the right turn or left turn, that time you are going to use the rack and pinion gears by engaging the gears. Okay, so rack and pinion gears are also used in some scales to turn the dial that displays your weight. So next gear, that is bevel gear. So bevel gear, that is kinematically the motion between two intersecting shafts, is equivalent to the rolling of two cones, assuming no slipping. The gears in general are known as bevel gears. When teeth formed on the cones are straight, and the gear is known as straight bevel, and when inclined, that time that is known as a spiral or helical bevel. In this figure you can see there is a bevel gear and the spiral bevel gear. When teeth formed on the cones are straight, that time that is called as a straight bevel gear, and when the teeth are spiral or helical, that time that is called as a spiral helical gear. So in straight bevel gears are useful when the direction of the shaft's rotational needed to be changed. That means when we want to change the shaft's rotation, that time we are going to use when direction of the shaft rotation we need to be changed, that time we are going to use these straight bevel gears. So they are usually mounted on shafts that are 90 degrees apart, but can be designed to work at other angles as well. The teeth on bevel gears can be straight, spiral or hypoid. Straight bevel gears teeth actually have the same problem as a straight spur gear. As each tooth engages, it impacts the corresponding tooth all at once. So there is a noisiness. So just like with the spur gear, the solution to this problem is to curve the gear teeth. So this spiral teeth engages just like the helical teeth. So the contact starts at one end of gear and progressively spreads across the whole tooth. So on straight and spiral bevel gears, the shafts must be perpendicular to each other, but they must also be in the same plane. If you were to extend the two shafts past the gears, they would intersect. So the bevel gears has many diverse applications such as locomotives, marine applications, automobiles, printing presses, cooling towers, power plants, steel plants, railway tracks, inspection machines, etc. So same as it is, worm and worm gears are also used. So the applications of the worm gears. So worm gears are generally used widely in material handling and transportation machinery, so machine tools, automobiles, etc. So I once again repeat the different applications, that is spur gears are used in electric screwdriver, dancing monster, oscillating sprinklers, okay, same as this cloths dryers. Helical gears or herringbone gears are used in curved that having the curved teeth, that's why they are very efficient and high capacity power transmission, also mostly used in heavy machineries. Also the straight bevel gears and spiral bevel gears are used in locomotives, marine applications, automobiles, printing presses, cooling towers. And worm gears are used in material handling and transportation machinery and machine tools and in automobiles. Okay, so in this session we cover the different types of gears. When these different types of gears we are going to engaging with each other, that time that became the gear train. Okay, so generally the bevel gears are also used in for the different drive to the different of automobiles, spur, rack and pinion. Also helical gears are used for the greater load at higher velocities. So gears are used in different machineries. So when these gears are meshing with each other, that time that is called as a gear train. So a gear train is a combination of gears used to transmit motion from one shaft to another. So it becomes necessary when it is required to obtain large speed reduction within small space. That's why the different types of gear trains we are going to use. So generally there are different types of gear train, such as simple gear train, compound gear train, reverted gear train, planetary gear train and differential gear train. Okay, so in next lecture we are going to see the different types of gear trains with their applications. So in this session we covered what the introductory part of the gears and different types of gears. Thank you.